so that we can connect directly when we land. I think the other area, we just had a workshop at our Charleston facility about just the mass amount of data that we have just in the factory. Because, like you were talking about for safety, a lot of repetitive injury, we put in robots to do, a lot of the work, but there's a massive amount of data that's being collected there right at the edge, right? Not only for robots, but we have non-destructive inspection, right? So once we, like, if you've seen the 777X wing, it's 110 feet long, and carbon fiber tape being laid up, right? And then that's inspected with sonar. All that data is in the factory, right? And we've got for things that are very high value like that, if there's any errors, we got to stop that tape immediately, right? So that has to be the real time, right? Another area we're pushing into really heavily is additive manufacturing. So doing metals, titanium, that's another area that we're looking at in the factory that has, there's video, and that's when you want to stop if that thing starts to go. So if anybody can solve cheap, massive amounts of data that we can store in our modular data centers, that would be great.
Go.
Yeah.
Excellent. And so, Sam, you've mentioned to me that Pixeom works across a number of verticals, but maybe you could share an example or a couple of examples from your experience and how you're using this.
Yeah, absolutely. So I feel like use cases in general will fall on a spectrum of immediate opportunity, people are willing to pay for this and deploy it today, versus maybe 5 years from now we'll get already this will exist, this use case will exist. And so our company is more of a general purpose virtualization and orchestration play, so we had to decide which was the low-hanging fruit to go after, which was going to be more longer-term opportunities. And so I know you guys have mentioned a lot of them. Some of the early ones that helped us gain our traction was the industrial space, safety, manufacturing, surveillance is a great one. These are all extremely clear use cases where you want to process the video as close as you can to the source of the data. But one of my favorite ones, which is kind of in the middle of the spectrum, and something that people can see every day when you go into retail stores. I think smart retail is one of my personal favorites. Whether it's some of the clothing kind of stores, or stores where you have the self-checkout lines like Target and some of those types of stores, or even like fast food chains that have the kiosks where you can start ordering food and all of that. That's been a very large growth area for us, and I think a lot of people would be surprised at how much infrastructure is required to make all that work. And a lot of whether it's publications out there or analysts might be sometimes creating a bit of FUD about the retail industry and how Amazon's eating up their business and people are shopping more online. I think retail is not going anywhere, and a lot of these retailers are investing in a lot of technology, a lot of sensors, a lot of infrastructure, and a lot of software systems. And to maybe build off the theme of even not just our chat, but chats before this, systems that are open and enable interoperability and are able to easily be deployed and managed at scale. And so my personal favorite is smart retail.
Great. So I know 5G we've already kind of mentioned briefly, but it's really top of mind for many people when we think about edge and IoT. So Christos, would you mind sharing your thoughts on how 5G will impact the decision of where we process at the edge, and what will change in terms of where we're seeing some of the data being processed because of what's enabled by 5G, and how that impacts the choice to process at the collection point or elsewhere?
Yeah, I think it's going to have a huge impact. I mean, we have to recognize, first of all, that with 5G, we're going to see far more data than what we see today, right? Because 5G is going to enable far more devices out there with its IoT, far more applications, so it's going to be an explosion of data, right? And also, we're going to be sending that data back to the cloud, or, although, we'll be interested, as a tech to do that tech calling, because we can make money out of that, but at the same time, we have to recognize that it's an application we have very stringent requirements. So if take that illustration with 5G, essentially will enable the collection of more data. That will also, make the need to move the edge very close to what that data collection means. So from the technical perspective, that's going to be where the tower is, whether the antenna you know, 5G antenna. Unfortunately, there are going to be so many of them because 5G is going to be, you know, it's like, you know, plethora of you know, small cell antennas. I don't foresee that it's going to be an edge node at every antenna. Depending again on the footprint, ideally that would be, you know, a good you know, use case. But essentially, maybe we can backhaul some of that in a mesh type of architecture. I do like the comment of federated data. That opens up another issue where it's like a connected car, you collect data at one base station. Maybe you need to forward some of that data as the car moves to the next small cell, right? And that's going to be, again, thousands of these small cells. You know, then you have to somehow pass some of that data to the next cell so they know that the car is coming. Same thing for, you know, if you're like on a train and you're watching video, right, as it goes from, you know, one small cell to another small cell. Again, some of the data you need to forward. So there's going to be open problems that we need to, you know, solve somehow. Another mobile edge computing, there's like grouping edge, developing this sort of like a handoff, if you remember, like roaming type of situation. And then also we need to work with other, you know, telcos as well, right? If you like AT&T, you go from AT&T small cell to like a Verizon small cell, right? What does that mean in terms of how we need to pass data from, you know, from one domain, one operator domain to a different domain, and how this is going to work? We need to work on the interface and so forth. So I think 5G is going to be great. It's going to open new good problems that we'll have to solve as far as data is concerned. You know, again, other use cases like AR, VR, and gaming also, you know, add a lot of traffic and lots of data. So from my perspective, as a telco, the closer to the collection point the edge is, the better it is for me, because I can, you know, I can serve my customers better in terms of user experience. But again, the reality is that we're going to perhaps deploy an edge node at every small cell. So perhaps we're going to see some, you know, small cells having that, depending again on what kind of applications, and maybe have more edge nodes at the center levels.
Great. And so you mentioned AR and VR, and I think that's a great seg to talking about some of the emerging use cases. So let's press on that one a little bit, and maybe Aaron, could you talk a little bit about how you see AR and VR technology impacting edge compute architecture in terms of what data is being processed at the collection point, and how it makes changes in terms of the edge and how we're thinking about processing and feedback?
Yeah, so I'll be a little cheeky out of the gate with this, right? The interesting thing about the edge is it's more of an enabling technology, right? It means that we had this conversation last year. It wasn't AR, VR. It was how is the edge going to work with AI? And the year before that, it was how is the edge going to work with blockchain? And the year before that, it was something else, right? So you have all these new applications that begin to be brought to this enabling technology, which is the edge. So, you know, we've now kind of learned AI is mathematical models being run really, really fast, right? We kind of, the magic's gone, we know how to push those down, those processes, and it's more about who knows how 777 engine data looks like, and you know, what do you do with it? So, you know, AR, VR, augmented reality, virtual reality, it's going to do a lot of interesting things. If you talk about the home, well, if I'm doing that, I want to play with my friends across the country. Right? So I want as fast as possible, whether it's 5G or, you know, fiber in my house. And there will be processing that happens locally, but for us to interact in real time, there's going to be a huge amount of data that has to cross the country. That said, AR, VR, and a lot of these industrial use cases, the railroads, in the factory, looking at the machines, putting together the airplane engine, putting together the engine itself for a car, that's probably all going to be done locally. Right? This is going to be like the LAN parties in the late 90s where we all brought our Game Boy, Xboxes, and plugged them in together, right? It's all one edge, all communicating, and that's how we're going to hang out, but we'll do it in VR and wave our hands, right? Or we'll do it to prepare the stuff to understand the 3D CAD model on real-time augmented. So the edge is going to be a core part of it, but it's going to come down to that use case of where do you want the data? Is the surgeon across the world controlling a robot, or is the surgeon across the world, you know, looking at what's going on? That data has to move. And it's going to be case by case, but eventually AR, VR is not going to be kind of the magical thing. It's going to be, here's the set, here's the data stream, this is the real data we want. We don't want the live video, right? We can overlay with our current video. We just want to be able to put context on this video. We want to be able to put the context of this is the screw that unlocks in step 7. It's turned 14 torques to the left with this particular tool, and then I've got the right tool in my hand as it happens. Those are where the AR VR comes together, and it's just an application that's running on the edge all along, right? The edge is that PC, it's the mobile phone that allows for these new ecosystems and opportunities.
And Christos, within that, how do you see, we've heard a lot of the mech and kind of mobile edge, how do you see that playing with an application like AR, VR, and where it's going to function in terms of processing data at or near the device versus in the mech, so to speak, or more in the cloud?
So yeah, I mean, first of all, I mean, people may wonder, what's AR, VR. We haven't seen that yet as a mainstream application, right? I mean, you don't see people walking around with those headsets yet, right? But we know it's coming, right? And so just to give you a perspective here, so if you want to have a good AR, VR experience, you need a connection minimum of 80 megabits per second. And the higher speed obviously means also much more delay. We don't know yet how this is going to play again, whether every small cell will be